Our lesson today is quantification of elements and compounds. Quantification of elements and compounds. This is a little difficult lesson for some people. Our lesson, and we'll try to understand it slowly but steadily. And this is a revision class, as I told you, right? Many students 2020 who went for the exam has scored a very good results. This is going live, and I'm not lying. Most of them got A's, 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 and very few B, and one or two I heard scored C pass. But as we are doing this year, last year also we did the Sunday class from 4 to 6 for 2 hours, and some of you also participated in that class as a grade 10 student, like the grade students are doing right now. Um, the studies that you are doing right now would be supporting to you in your exam, which might be coming in the February 2022. Well, quantification of elements and compounds, a little difficult for some of you. Let's see. As usual, this is going on live, and if there is anyone, 71814618 can call me or go to Anugrah and find more information there. Right. Quantification of elements. You know that we have to count. We have to have the uh, calculations. But when we are counting, when we are counting anything, that we have certain units. If you say, if I'm going to buy the books, I will say a dozen of books. A dozen of books means 12 pieces there. So the combination is there, the number and the unit. Quantification of elements, quantifying. We are going to deal with the quantity, quantification of elements. Quantification of elements and compound. And before going to the lesson, I'll ask you several very little simple questions regarding the unit and the pieces of things in that. I think that you would respond me, even though it is so early in the morning. This is what I want to ask you. I got um, oranges. I got oranges. Orange. Check. Got- I got orange fruits, right? I got orange fruits. One, two, three, four, six, seven, eight, nine, 10, 11. How many orange fruits are there?
12.
12. There are 12. If I can have a unit for that, if you say a unit, how much is that? 1 dozen. My spelling correct. 1 dozen. Dusi mekai. How many dozens are there?
One,
How many pieces of oranges are there?
12.
12.
Well, and I'm going to make a bunch of fruits. A bunch of fruits with. right? A bunch of fruits or um, a bucket of fruits. This is bucket 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And each contain one orange, two mangoes, one orange, two mangoes. Now, my simple question is, how many, how many buckets of fruits are there? How many?
12.
12.
12.
And how many units of, if you say buckets as a unit?
1 dozen.
1 dozen. How many oranges are there?
12.
12, or 1 dozen of orange. How many mangoes are there?
24. 24.
24. 24. And how many uh, dozens of mangoes are there?
2 dozen. 2.
1 dozen.
How many mangoes are there?
20.
2 dozen.
How many dozens of mangoes are there?
1 dozen.
How many dozens of mangoes are there?
2 dozen.
2 dozen.
2 dozen.
2 dozen.
Yeah, if you have 24 and then divide by 12, you got 2 dozen. Understood? That is the point that you get confused. That you get confused. If you isolately, if you individually consider the number of mangoes, you got 24 pieces. And if you consider that amount in dozen, you got 2 dozens. But the 12 comes as you have all together combinedly put over here, right? So don't get confused with that. And that's the story of mango. And we went on the number of pieces and the unit as we call dozen. Right. Now I'm going to deal with the atoms. Going to deal with the atoms. Now this is of course pretty easy because we can go with the number. As we can see, we can count them. It was a problem that when I was in the school, I could remember that grade 10 or grade 11, about 550 uh, boys were there, and we wanted to count the papers in the morning for the term test. Right? When we count, we have to count 550 papers, right? It's not easy. Isn't there any other way of counting the papers without counting? Is there any other method of getting that 550 papers? Yes or no? Should we go? Huh?
Yes.
Yes. Or how?
By measuring.
Measuring of what?
Measuring, putting some tones in another and putting the papers in another.
Measuring what?
Measuring the papers.
Measuring the paper. I mean, measuring the paper is what? I mean, measuring means you can measure the length and breadth, you can measure the weight, you can measure the mass.
From the measuring stones.
Measuring. Yeah. Well, what I suggested was, you know, you count 100. You can count 100, no problem. And then measure the mass. Count 100 papers and then measure the mass. Right. If you say 100 gram, so you got 100 gram, 100 papers. So what you have to do is take the balance from the lab and then measure 550 gram. When you measure 550 gram, exactly there are 550 papers. 550 papers. So the 550 papers, now you have to break it into the 11 classes. 11 classes. So then you can measure 55 gram, or rather, how many? 10. So you can measure, right? You can measure the mass, then you can find out the quantity. And there's a relationship. We understand that there's a relationship. That is the mass and number. The mass and the number. As I told you that if you consider 100 gram, there you have 100 papers. So you can measure if the fruits are equal in size, right? Equal in size, you can measure the mass, then you can count the number of mangoes. If you are counting in thousands rather than counting 1, 2, 3, 4 like that, you can measure the mass and then calculate the quantification of element and compounds will be the same. Scientists did lots of experiment in this, and Avogadro was very much successful in that, right? Counting the number of atoms by considering the mass. If you can have 100 gram of papers, you can have 100 papers, something like that. The Avogadro could find out that the number of atoms available in certain fixed mass is 6.022 times 10 to the power 23. There are 6.022 times 10 to the power 23 amount of atoms. If you consider a fixed amount of mass, and what is that fixed amount of mass? What is this fixed amount of mass? And we're going to find it out. Yeah, later we found out that this fixed amount of mass is said to be 1 mole. 1 mole of substance, right? If you consider 1 mole of carbon, there you have 6.022 times 10 to the power 23 amount of atoms. 1 mole of carbon, C612 isotope. Now, if you consider carbon, if you can't understand anything, you can disturb me. If you consider C612 isotope, 1 mole, you can have 6.022 times 10 to the power 23. If you can have 1 dozen of 1 dozen of oranges, there you can get 12 pieces. 1 dozen, 12 pieces, 1 mole, 6.0, 0.22 times 10 to the power 23 amounts of atoms. If you say carbon, or if you say oxygen, right? Oxygen, 1 mole, you can have 6.022 times 10 to the power 23. You can express either way. If you can have 12 pieces of oranges, you can have 1 dozen. If you can have 1 dozen, you can have 12 pieces of oranges. If you can have 6.022 times 10 to the power 23 amount of atoms, they are 1 mole. Or if you have 1 mole, 6.022 times 10 to the power 23. Now, what do you mean by a mole? What do you mean by mole? How can you express it? That's another problem we have. As we know that in the lesson, the mole, we know that the number of mole available is equal to the given mass divided by molar mass, right? The number of moles available is equal to the given mass divided by the molar mass. What do you mean by molar mass? That's one problem. What do you mean by the molar mass? And what is the given mass, right? So what is the mole, and how are you going to connect with the number of atoms available? Number of atoms available. So we know now, if you have 1 mole, 6.022 times 10 to the power 23 amount is available. Now, we have to go in different directions, right? Well, if I come over here, now I am going to jump. I just only talk about carbon, right? Oxygen. What about if you consider carbon dioxide? Now it's not an atom, or it's not an only one element. You have carbon and oxygen combinedly a molecule. A molecule. Now, as I told you that a bucket of uh, fruit combined with 1 orange and 2 mangoes. 2 mangoes, right? If you can have 1 mole of carbon dioxide, how many molecules of carbon dioxide can be there? If you can have 1 mole of carbon dioxide, 1 mole of carbon dioxide, how many molecules are there? How many molecules are there?
0 point
How many?
6.02 times 10 to the power 10.
6.022 times 10 to the power 23. Whether it is a molecule, whether it is atom, the number is fixed. Whether it is 1 orange, if you consider the dozen, 12 pieces are there. And if you have 1 orange and 2 mangoes combinedly make a 1 unit or 1 basket or 1 basket, right? Then there are 12 such combinedly made buckets are there for 1 dozen. And if you have carbon dioxide, it's 1 unit, and then you can have 6.022 times 10 to the power 23 in 1 mole. of carbon dioxide. My second question, if you consider 1 mole of carbon dioxide, how many carbon atoms are there? In
One,
One.
one,
in one, don't misunderstand. I'm asking a in 1 mole of carbon dioxide, how many carbon atoms are there?
6.02 times 10 to the power 20.
Yes. 6.022 times 10 to the power 23. How many carbon, how many carbon atoms are there in one molecule?
One.
You have one. One. Again, I'm asking, if you consider carbon dioxide molecule, right? How many carbon atoms are there in 1 mole of carbon dioxide? 6.022 times 10 to the 23. And if you consider carbon dioxide, 1 molecule, how many carbon atoms are there?
One.
One.
One. My second question, that what I'm going to ask you. If you consider 1 mole of carbon dioxide, 1 mole, how many oxygen atoms are there?
2 times 6.02 times 10 to the power 20.
Yeah, very good. 2 times 6.022 times 10 to the power 23. 2 times. 2 times. Because there you got O2, 2 oxygen atoms. I'm asking the same next question. How many, how many, how many oxygen atoms are there in one molecule? How many oxygen atoms are there in one molecule?
2.
two,
2 atoms. Our children get confused with this one. Let's see. I will give you the questions and then see how you are going to answer that very clearly. Now, I am going back. We got a problem. We got some doubts here. What is that? What is the molar mass? What do you mean by molar mass? And what is the relationship with that? Now, as I told you that when we got a problem by counting the number of papers which are to be delivered, distributed among the students in the term test, there are 11 classes, right? So one class, if you say 50, then you have to count them. Counting the total number is a problem, then counting like at least 50 or 55 is a problem. So what we could do is just measure 100 gram and count the number of papers. If you say 1 gram, 1 paper, so then you have 100 pieces in 100 gram. Avogadro found out that relationship, right? What he did was he measured the mass. When you consider carbon has 12 massed particles. 12 massed particles. In an atom carbon, in the nucleus, you have neutron and proton. The neutron and protons are the massed particles. There you got 12. And he wanted to measure the mass of carbon atom. He measured the mass of carbon atoms in gram. So he found out what is the mass of carbon atom. It is 1.99 times 1.993 times 10 to the powered negative 23 gram. So 1.993 times 10 to the power 23 gram. That's the mass of carbon C612 isotope, right? Then now he was trying to express. He was trying to express the mass, show the mass and the quantity or the amount of substances available. So he was trying to introduce the atomic mass unit, AMU. I mean, to express the mass of other one by using a standard unit. So actually they were trying to get hydrogen, oxygen as this unit, and finally they decided to get the mass of carbon to express that. If you have carbon, right, if you have 12 pieces, 12 subatomic particles with the mass, right? So from there, he went on introducing the atomic mass unit. So you divide this one by 12. If you divide by this one by 12, what was the answer? According to, yeah, if you divide this one, then 1.66 times 10 to the power negative 23. 1.66 times 10 to the power 1.60 times 10 to the power negative 24 grams. So one particle. So one piece of, if you say one subatomic particle, the mass would make 1.66 times 10 to the power negative 24. And that is considered as AMU, atomic mass unit. Atomic mass unit. Then, how did we get that one? We got that by dividing the mass of C612 isotope, mass of one atom of C612 isotope by 12, because it got 12 mass particles. And then the number came 1.66 times 10 to the power negative 24. So he was trying to give the standard application to it. And if you consider any other one expressing by using this unit, right? You could express, if you consider another one, like mass of sodium, mass of sodium, mass of sodium atom divide by AMU. Now you are going to give a relative value. Relative value. What is relative value? Relative atomic mass. Relative atomic mass. This relative atomic mass is considered as AR. relative atomic mass, right? Now, mm, we can write this one something like this, relative atomic mass. We can write that mass of sodium atom. It has been given in your book. It is 3.819 times 10 to the power negative 23. 3.819 times 10 to the power negative 23 grams. And AMU. What is AMU? You can expand it. 1 upon 12 times the mass of carbon atom. The mass of carbon atom. What is the mass of carbon atom? 1.993 times 1.993 times 10 to the power negative 23 gram. So this is a big one. This is a big one. And the final calculation would give you 23. So sodium's relative atomic mass is 23. Sodium's relative atomic mass is 23. Now, somebody might get confused or get lost on its way. What's the use of having this atomic mass unit, relative atomic mass, and then counting the number and all? And what is the story? How you are going to link the one that you introduce that 100 grams, you take 100 pieces of papers are there? Well, it's pretty easy. I'm going to tell you. Because if you are to work with the grams and the masses, as you can see, there it's a big number. You know that the decimals are there, and the decimals you have is very pretty high. If you say minus 23 or negative 23, it's a big one. So if you can have relatively the value, so then counting is pretty easy. Now, now you have sodium's AR, that is relative atomic mass is 23. And if you can have 23 grams, if you can have 23 grams, and you have 1 mole of sodium there. If you can have 1 mole of sodium, then you can have 6.022 times 10 to the power 23 amount of atoms. I told you that number of moles equal to given mass divided by capital M. Capital M. That is what we are referring here. That is molar mass. Molar mass. Mass of 1 mole. Mass of 1 mole is equal to the relative atomic mass in gram. Relative atomic mass in gram. Is the message for me? You got a problem or no? Let me check. No. You can ask any questions, no problem. Right. Now, no. Let's go. Continue. You can have a relative atomic mass by dividing the mass of the particular atom, by atomic mass unit. I told you the atomic mass unit is measured by the mass of C612 isotope by 12. As why did I divide by 12? Because it got massed particles, 12 massed particles. And then the final answer, it was to say that the atomic mass unit is, we could find out the value, 1.66 times 10 to the power negative 23 negative 23 gram. Right. Now, I'm going to introduce you what? The relative atomic mass and relative molecular mass. Relative molecular mass. MR, not Mr. Relative molecular mass. What is that? If you consider carbon dioxide, it is a molecule. It's a molecule. It's a molecule. That means it is made of three three atoms. It is made of two types of atoms. Two types of atoms made of three atoms, two types of atoms. And it has the mass, sorry, it has the mass. It has the mass in gram, right? It has a mass in gram. And I'm going to express a relative value. Relative value, how? Divide the mass in gram, divide mass of carbon dioxide molecule by AMU, atomic mass unit. Then you can have MR, that means relative molecular mass, relative value of one molecule, relative mass of one molecule of carbon dioxide. Well, if you consider the mass of carbon dioxide, I'm not going to measure it because it's very difficult for me to measure, but I'm going to find it out from the given source. As you can see, it is given in your book, 7.31 times 10 to the power negative 23. The mass is 7 point, what's the value I told? 31. 7.31 times 10 to the power negative 23 gram. That's the mass. If you measure carbon dioxide's mass by using any sort of method, I don't know. And then AMU, you can introduce here two ways. One, a straight way you can get this I value. What is it? 1.66 times 10 to the power 23. Straight way you can write over there, or you can write this one. Mass of one carbon atom, C612 isotope, and divide by 12. Anything you can write here. Anything you can write. AMU, or you can write 1 over 12 times mass of C612 isotope atom. Anything. And final calculation, you can have 44. 44. There is no gram because here gram, and then gram to gram cut off, it's a relative value. So you can have 44. That's a method normally you can have to find out the relative molecular mass, relative atomic mass, relative molecular mass. But we don't want to go on calculating. If you say, if you want to find out relative molecular mass of CaCO3, calcium carbonate, right? You have to measure the mass of calcium carbonate in grams, and then mass of calcium carbonate, then divide by 1 over 12 of C612 isotope atom mass of, so it's very pretty hard because calcium carbonate, if you are going to measure the mass, is difficult. Therefore, there is a short method of finding the mass. Standard. Now, after doing these calculations and all, the scientists were able to find out the relative atomic masses of all the atoms: hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, calcium. So all these elements, their relative atomic masses are given to us. Among them, there are some important ones like hydrogen, right? One. And if you say carbon 12, nitrogen 13, right? Oxygen 16, and sodium 23, magnesium 24, aluminium 20, can't remember, chlorine 35.5, potassium, calcium 40, right? So all these are given, and if you are going to have a calculation by using this, no worries. This has to be given to us. It has been given within bracket CA40, like this, CA40, C12, O 16, something like that. That has to be given, and better you can remember it. Fine. Then, how can we find out the relative molecular mass of calcium carbonate? Relative molecular mass of calcium carbonate. I'm going to find out the short method, not the long method. Long method is to finding out the mass of calcium carbonate in gram and then divide by AMU, atomic mass unit, and then do the calculation and find. I don't want that. I can write this one, MR of calcium carbonate is equal to AR of calcium. AR of calcium, relative atomic mass of calcium, plus AR of carbon, right? Carbon plus, then are you going to write over here? 3 times AR of oxygen, because there are 3 oxygen atoms. And then AR of calcium, relative atomic mass of calcium is 40. From where you got it? We have been given it, and I know it. Carbon is 12, and oxygen is 16, but you have to multiply it by 3 because you got 3 oxygen atoms. And then 40 plus 12, it is 52 plus 48. It will make 100. So, relative molecular mass of calcium carbonate is 100. And this is what I call M. This is what I call M. I can make M from this one. M means the mass of what? molecule, right? A mass of 1 mole, mass of a mole of molecule. OH. So that value is equal. Now Avogadro is going to give a wonderful idea in that way. He's going to tell us, if you consider one mole, one mole of atom, right? 1 mole of atom, it is equal to the mass of 1 mole of atom is equal to mass uh, taken the mass of AR in gram, right? Mass of relative atomic mass in gram, or molecule mass of MR in gram. 1 mole equal, if you consider atom, relative atomic mass in gram, 1 mole of molecule, relative molecular mass in gram. And I'm going to simplify it like here. If you say, now then he says, if you consider 1 mole, there you have 6.022 times 10 to the power 23 amount of atom or amount of molecule. Example. I'm going to go with that here. Consider carbon. Or I'll take oxygen. You kept silence listening to me for that long description, and now you're going to answer me. If you consider oxygen, right? 1 mole of oxygen. There you got atom. Mass of AR in gram. What is the relative atomic mass of oxygen?
16.
18. Take it in how? Take it in gram. If you consider 16 gram of atom oxygen, there you got 1 mole. And then you have 6.022 times 10 to the power 23 amount of atoms. Could you understand what I said?
Yes, sir.
Yes, sir.
Yes, sir.
Nice. Waiting to have the female voice. If you have 1 atom of oxygen, there you got the relative atomic mass 16, and then consider it in gram. Then you have 1 mole, and then you have 6.02 times 10 to the power 23 amount of atoms. What about the molecules? If you consider molecules, what is MR in gram? What is the relative molecular mass of oxygen?
32 gram.
How you get that one? It's equal to AR of oxygen. 2 AR of oxygen. AR means relative atomic mass. 2 times. 2 times AR is 16. Then take it in gram. That's how you said 32 gram. If you can have 32 gram of oxygen molecule or 2, there you got 1 mole. And then you got 6.022 times 10 to the power 23 amount of molecules. Molecules. Okay. Then the capital M of N equal simple M over capital M is referred as MRO AR in gram or MR in gram. Then the capital M is equal to, if I say, gram per mole. Grams per mole. Example. Capital M of carbon dioxide is equal 44 gram per mole. If you say capital M of sodium equal to 23 gram per mole. Now the work is done. And now we can go for the questions and how we're going to understand it and how we're going to solve it out. We're going to evaluate my long descriptions. You happy about that?
Yes, sir.
Yes, sir.
If there was anyone who could not understand, now you can understand or something like that. Is there anyone? I was, yeah, at the beginning it was confused. Now it's quite okay, not that much. Ne? එමෙතන ඉන්නව නේද? මේක අපි ප්‍රශ්න සාකච්ඡා කරලා පස්සේ you will be able to get a very good understanding about that. Shall we go with that one?
Okay, sir.
The questions. Right. Anything you want to ask that you could not understand even this description? Any confusing, any place that you get confused? No problem. Let's go. Let's go. Take your book and write the questions and then proceed. Right? Then we'll proceed. Now the problem comes, you will get lots of problems. No problem. One. Question number 1. Question number 1. Question number 1. Roman number 1. What is meant by atomic mass? What is meant by atomic mass unit? What is meant by atomic mass unit? The answer?
The mass of the unit relative is the mass of the other atoms.
Yeah. It is. The answer is It is the unit taken by dividing the mass of an atom C612 isotope by 12. Isotope by 12. Okay. It is equal to 1.66 times 10 to the power negative 23 or negative 24.
Negative 20%.
Negative 24. Yeah. It is equal to 1.66 times negative 24. What is meant by atomic mass unit? My second question. Second question. If the mass, if the mass of, if the mass of, if the mass oxygen is, if the mass of oxygen is 2.66, if the mass of oxygen atom is 2.66 times 10 to the power negative 23 grams. Find out the relative atomic mass of oxygen. Now, how are you going to find it out? Step one. Step one. Step one. Write the equation. What is the equation? Should I share this screen? Is this clear?
Clear, sir.
Yes, sir, it's clear.
Step one. I can share if you want the screen. Step one. Write the equation. Mass of oxygen atom divided by AMU, atomic mass unit. You can write atomic mass unit in any way. Mass of oxygen atom is 2.66 times 10 to the power 23 and gram divided by AMU. That means 1 over 12 multiplied by mass of C612 isotope. And what is that one? What is the mass of C612 isotope? 1.993 times 10 to the power negative 23. Again, what's that? 1.993 times 10 to the power negative 23 grams. Or else you can straightway write 1.66 times 10 to the power negative 24. Then final calculation will be 16. No gram. Okay, that's a step 2. And then calculation will give you that. So you can write, you can use either way. You can straight way or given here. Can I go to the other one? Question number 3. I don't know whether I'm going in the clear rhythm. Are you okay with that?
Yes, sir.
The way I'm going?
Yes, sir.
Most of you got the problem with this one, and I hope that this would support you, and not only this, and we have one more to go. Right, my next question. Next question. If 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 hmm, if C equal 12 or equal 16, CA equal 40, simple A, express the relative molecular mass of, express the relative molecular mass of CaCO3, express the relative molecular mass of calcium carbonate. How are you going to express it? It's pretty easy. MR of CaCO3, I don't know whether you can see this. MR of CaCO3 equal AR of CA plus AR of carbon plus 3 AR of oxygen. Now, AR of calcium is 40 plus AR of carbon is 12 plus 3 AR of oxygen is 3 times 16, and you will get finally 52 plus 48 and equal 1 gram. Express the relative molecular mass of calcium carbonate. Question B. Question B. What is the molar mass of, what is the molar mass of 1 oxygen, or XYGEN, oxygen atom? Actually, that can be expressed as atomic molar mass. What is the molar mass of oxygen atom? Or atomic molar mass of oxygen? Your answer?
16 gram per
16 gram.
Per mole.
Yeah. 16 gram per 16 gram per mole is required. 15 gram per mole. My second question. Oxygen or XYGEN. Oxygen molecule. And I told it molecular molar mass. If you say oxygen atom, it is atomic molar mass. If you consider oxygen molecule, it is molecular molar mass. Yeah, what is it? How are you going to consider that? So, oxygen molecule. That means oxygen molecule. It means it's something like this. MR, right? In MR of oxygen or 2. That means 2 AR of oxygen. So 2 AR of oxygen is equal 2 times 16. And then you will get 32. But asking one is what is the molar mass? Asking one is molar mass, right? So you have to express this one in gram. 32 gram per mole. 32 gram per mole. You okay?
Yes,
yes.
sir.
And my next question. See. Now, we'll go to another one. What is the molar mass of my 1, 2, and third one? Third, what is the molar mass of calcium carbonate? Calcium carbonate. How can we find it out? Molar mass. We found out the MR of, okay, it is equal MR of CaCO3 in gram. Then calcium carbonate we found out earlier 100 gram per mole, right? This one we calculated earlier, right? Now the problem comes. This is A, B. This is third question, right? We are going with the question. It's C equal blah blah blah. Wait. Now the problem comes. My fourth question. Now the problem comes. Now the problem comes. Now the problem comes. If there are, if there is, if there is, if there is 4.4 gram of carbon dioxide if there is 4.4 gram of carbon dioxide. My question number how many moles CO2 are there? If there is 4.4 gram of carbon dioxide, how many moles of CO2 are there? Anybody who can't find out,
0.1.
let's say. Number of mole is calculated. N equal simple M over capital M. Number of mole is calculated by N equal simple M over capital M. Simple M is the given mass, 4.4 grams. Capital M is carbon dioxide's molecular molar mass. We know it. We know it. What is that? 44 gram per mole. Somebody might get confused. What is that? Well, MR of CO2 in gram would give 1 mole, and C means 12, O means 16 times 2, and then that will make 44 grams, right? That is how it is taken. 44 grams per mole. Then you are going to substitute 4.4 divided by 44. This is gram. This is gram per mole. So you cut off gram to gram, and then you can have mole. Per mole comes mole, and then the answer 0 point 0 point
1.
0.1 mole. 0.1 mole. My next question. My next question. How many CO2 molecules available in 4.4 grams? How many molecules are available in 4.4 grams of CO2? How are you going to find it out? According to Avogadro, one mole of CO2 contains 6.022 times 10 to the power 23 molecules. 6.022 times 10 to the power 23 molecules are there. And he said 1 mole, right? Then the 0.1 mole, 0.1 mole, you have to do 6.022 times 10 to the power 23 is available in 1. What you need is to find out 0.1. Understood? This is 1 mole and this is 0.1 mole. How can you do that? You have to multiply this. Only one, the change is that you have one decimal more, right? So then what's the answer? 6.022 times 10 to the power 20,
4.
20,
2.
22, not 24. Because this is 0.1 minus, right? That is, which is equal 10, sorry, 1.0 times 10 to the power negative 1. Right? 0.1 equals 10 times, right, am I correct? This is not 10 times, right? 1 time. It's equal to 10 to the power negative 1. That means you have to take away 1. And this much of molecules are available. Right. Shall I ask you another question to put you in trouble? Okay. See, how many oxygen atoms are there? How many oxygen atoms are there? 1. In CO2 molecule. 2. 4.4 gram of CO2. How many oxygen atoms are there in CO2 molecule? And 4.4 gram of CO2. The first answer.
2.
Yeah. The answer for the first one is, are there, girls? Are you there? You're scared? No? Yes, the answer is in CO2 molecule, 2. 2 atoms. 4.4 gram of carbon dioxide. How many oxygen atoms are there?
6.022 into 10 to the power 22 multiplied by 2.
Very good. There you got 6.022 times 10 to the power 22 carbon dioxide molecule, and among their oxygen atoms 2, so you have to multiply by 2. Remember, this is not 23, right? In 4.4 gram. That's why this was made to 22. Otherwise, it will be 23. So you have to multiply by this one. Then you will get 4, 4, 0, 12 times 10 to the power 22. But you don't put two numbers. So 1.2044 times 10 to the power 23. Okay. Right. Are you okay with that, girls?
Yes, sir.
Is there anyone who was much in trouble in doing these calculations with this, and now you find quite okay? Any comments? අපේ උත්සාහය සාර්ථකයිද කියලා බලන්න. කවුරු හරි හිටියා නම් අනේ සර් මට ඒවා තේරුම් නැතුව හිටියා. දැන් නම් ටිකක් තේරෙනවා වගේ කියලා. ඔන්න මම අපහසුතාවයටපත් වෙන්න යනවා. Yeah. And most of you said yes, we can't understand this one. අද මේ උත්සාහයේ සාර්ථකත්වයක් තියෙනවද කියලා යහන්නේ.
Yes, sir.
Yeah, sir.
Then before and now.
Again. Oh. නැත්නම් අපි පාන්දර 4 ඉඳන් නැගිටගෙන නේද මේ කරපු වැඩේ. හොඳයිද? ප්‍රතිඵලයක් තියෙනවද?
Yes, sir.
So,
අපි ටිකක් සංකීර්ණ තැනකට යන්න. එහෙම ප්‍රශ්නයකට උත්තර දෙන්න බලමුද? Okay. ටිකක් අමාරු පහේ දෙන්නද? හොඳයි. මෙන්න එහෙනම් එහෙම එකක්. හරි. ටිකක් අමාරුයි. මම දන්නේ කීවෙනි question එකද කියලා. ලියාගෙන ආව නේද? එකම ලියාගෙන ගියේ. ආයි දෙවෙනි ප්‍රශ්නේ. ඒකේ භාවිතේ නේ. Question number 2. Question number 2. Question number 2. A chemical reaction is given below. Answer the question. ANSWER. Answer the question. By using the chemical reaction is magnesium reacts with hydrochloric acid and make magnesium chloride plus X plus Y. My first question. What are X and Y? What are X and Y? I write here Mg14 H1 Cl 35.5. What are X and Y? X,
Magnesium.
Chloride.
magnesium chloride. How can I write magnesium chloride?
MgCl2.
MgCl2. That is X. And then Y?
H2.
What?
H2.
Hydrogen gas. H2. Question number 2. Rewrite the equation. Rewrite the. Is this equation or what?
Chemical reaction.
Rewrite the reaction now. balancing it. And the equation balancing it. This is it, yeah. Magnesium with hydrochloric acid. What is X? MgCl2 and Y hydrogen gas. So once you balance it, you got 2 chlorine, 2 hydrogen. Can I put 2?
Yes, sir.
Now is it balanced?
Yes.
Now you know that what I'm going to do. I'm going to put you in trouble. Third one. Third one. If, 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 uh, if 3 point uh, 6 5 gram of HCl is used. If 3.65 gram of HCl is used, put you in trouble. Simple A. How many? How many? How much mole? How many moles of magnesium are used? If 3.65 gram of HCl is used, how many moles of magnesium are used? How many of you can answer that question? How many of you can answer
3.65 gram divided by 2.
again?
3.65 gram divided by 2.
3.3.65
6 grams divided by 2.
gram divided by 2. 2. First, you have to find out the amount of moles here. The amount of moles here. How can you find it out? Simple N equals simple M over capital M. Okay. Then you have 3.65 divided by 36.5. Y HCl. HCl. H indicates 1 plus Cl is 35.5. What I'm trying to find it out is MR of HCl. Then you can have 36.5. To find out capital M, you have to put that one into gram per mole. Then you have 36.5, 3.65, 36.5. What is the value if you divide this one? I'm not clever at maths. Yep.
0.1.
0.4. Are you sure? 0.1 or 0.01?
0.1, sir.
0.1 mole. 0.1 mole. If 3.65 gram of HCl is used, now the problem comes, right? I'm writing that again. HCl with Mg. Sorry, I want to make it bigger. Oh, yeah, well, I'll with the space. Mg plus HCl, MgCl2 plus H2. It is very clearly indicated that magnesium, you took 1 mole. HCl you have to take 2 mole. Magnesium chloride, 1 mole, because it is here 1. Here it is 1 mole, right? Now, you are going to put that the values and tally this one. If you can have 2 mole, magnesium will be 1. If you have 2 moles of magnesium, sorry, hydrochloric, magnesium will have to use 1 mole. If you can have, how many moles are there? 0. If you can have 0.1, this one,
0.1 divided by 2.
0.1 divided by 2. 0.1 divided by 2 equal 0.05 moles. 2 is available if you have 1. Now, yeah, if you say magnesium, no, I made the other way around. Right? You have to get something like this. Magnesium to take 1, right? If you consider magnesium 1, there are 2 moles of HCl. 2 mole of HCl. That means 2 divided by 1, right? And if you can have 0.1, that 0.1, you have to divide 0.1 now by 2. So if you have 2 moles magnesium 1, then I got the relationship like here. And now if it is 0.1, so you have to divide that. Now you know that I'm going to put you in trouble again. What is that trouble? How many? How many? Simple B. You will not be given the question like this, right? How many? How many hydrogen molecules are made? How many hydrogen molecules are made? How many hydrogen molecules are made?
Two.
2. Now,
No, 1.
1.
1. One. You got it. Now you can hear. Hey, how many hydrogen molecules?
6.022 times 10 to the power 23.
Yes. But yeah, just consider again. Now look at here.
2 times.
Is it 2 times? Don't worry, don't go with that. How many? If 3.65 gram of HCl is used, how many moles of magnesiums are used? And the number B comes under that. How many H2 molecules are made? That means you want to find out the number of moles here of hydrogen. The number of moles of hydrogen with 3.65 gram of HCl. How many moles of hydrogen are made? The same, huh? The same amount like magnesium. No?
1 mole.
1 mole?
0.1 mole.
0.1 mole? 0.1 mole? Or 0.05 mole?
0.1 moles.
Why? What is
Sorry,
this
sir.
sound? Huh?
0.05 mole.
0.05 mole. My dear, if you say magnesium 1 mole, HCl 2 mole, magnesium chloride 1 mole, H2 1 mole. Understood? That's correct. Is that correct?
Yes, sir.
Yeah. Then how many moles will be made in there? How many hydrogen molecules will be made? 6.022 times 10 to the power 23 because you got 1 mole. But now say hydrochloric 0.1. Hydrochloric is made 0.1, right? But as 2 over here, magnesium will be half of that. That means 0.05 mole. Am I correct?
Yes, sir.
Huh?
Yes, sir.
Yeah. Then the same amount, if you say magnesium 1 mole, hydrogen 1 mole, the same amount will be also the hydrogen. Then the number of moles of hydrogen, number of moles, number of mole of H2 with 3.65 gram of HCl, right? HCl. Number of moles of H2 with 3.65 gram of HCl is 0.05 mole. Then the number of H2 molecules are 6.022 times 10 to the power 23 multiplied by 0.05. What is the value? 10, 11, 30. As the decimals are there, 1, 2. So you have to get another 2. Am I correct? So how many decimals should be there? How can I get that idea? Well, I'll make it. I'll make it out. I'll make it out. The best thing is to find out here 6.022 times 10 to the power 23 multiplied by 5.0 times 10 to the power negative 2. Correct? Negative 2. Okay. I put this one into negative. I do. I didn't.
Yes, sir.
Now multiply this one. Yep. 10. Right. So you put now remove 2 from here times 10 to the power 21. And then put here 3.0110 times 10 to the power 22. Harduman. Huh? Okay. ඒක නම් ටිකක් අමාරුයිනේ. ඒක ටිකක් අමාරුයිනේ.
Yes, sir.
This kind of questions will not be given. Don't worry. Okay. I just gave you for your A-level applications, you know, that you have to think, you have to concentrate on the questions given that sort of way. Okay, with that, I hope to conclude today's session. Are you happy about the day today? The 2 hours you spent with me?
Yes, sir.
Yes, sir.
What? Okay. Then see you Wednesday as usual time. As I told you, the results are out. I'll try my best to get the ones who sat for the exam to talk to you, and the things that you have to do during this COVID-19 pandemic is very difficult to concentrate yourself, and yeah, it's hard. Then I'll see you on Wednesday as usual. Bye-bye then.
Bye, sir.
Bye, sir. Thank you, sir.
Have a nice day, sir.
Thank you, sir.